I made this little jig for measuring curvature, but I found it's not quite accurate enough. The holes down here, I just couldn't drill those precise enough, and this is actually my second attempt. So I figured some kind of milling table would be the solution, and I ordered this one off of Vevor. It wasn't too expensive. And the reviews for that same item on Amazon said it needed a bit of work to get it to work smoothly, so I knew I was in for a little bit of trouble. And trying it out for the first time, this adjustment worked just fine, but for the side to side, I couldn't even get that crank to go on there properly. And when I turned the crank, the table kind of moved, but not really, so I had to take it apart. And what I saw inside was this lead screw nut. That's the nut that goes on this lead screw here for adjusting side to side, was broken in half. The mounting bolt for this half was just sheared off and the other one was bent. The lead screw looked kind of okay, but on closer inspection I found some defects on it. And I'd also never been able to actually fit the nut on here more than one turn or so, then it's just kind of jammed up. Then looking at the box it came in, the screw for the hand crank on the right side went to about here, and curiously enough there's a hole in the box right about here. And this styrofoam is not the strongest. I can easily squish that with my fingers. So I think what probably happened is this box fell off a forklift or something, fell on his right side on a concrete floor. The styrofoam was not enough to absorb the shock, so this lead screw just kind of went through the box, made this hole right here, and that took the impact. And so the entire impact was on the end of this lead screw, which through here transferred the force through this nut to the rest of the table, which is why this nut split in half. Also the threads on here got slightly damaged, and the thrust bearings in here had some dents in it too. And no surprise I couldn't get the nut on here because that got squished a bit just from falling on the end of it. So that thread is just bent and compressed. And with that lead screw removed, just rolling it on the bench, I can tell that it's bent just a little bit. So I contacted Vevor product support and they sent me a new lead screw and nut straight from China. It took about 2 weeks to get here, whereas the table itself actually, that arrived within 2 days of ordering, so clearly that was in the more local warehouse. And checking that new lead screw, it actually has more wobble to it than the old one. So I was starting to wonder what kind of gorilla do they use for their shipping, but examining the packaging, that was actually undamaged. And there's no sign of bending on here, it's just this part is on there crooked. And it's like, how could they possibly have chucked this up so crooked? And by crooked, I mean it must have been in the lathe this crooked. And examining the ends of these lead screws, the way that sort of sticks out from the middle here, it's concave on the end. I think these threads were actually rolled onto the lead screws, that is, they weren't cut but rolled between dies to make that screw thread, just like they make most screws nowadays. And rolling a screw thread involves a lot of deformation of the metal, and even though the screw thread itself is straight, I think maybe the rolling dies kind of just left a kink on the end where they finished. And now I've got both of these lead screws with a bent part facing down, and if you look at the last bit of thread on here, if I roll these over, you notice that thread bit ends in exactly the same place for both of those. So I think what happened is they turned the end cylindrical and the threads on there for mounting it, and then ran it through the rollers to put the actual lead screw thread on there, and where that lead screw thread ended, it left just a bit of a kink. So now I'm wondering if I can bend this thing straight, because if those threads on here were rolled on, it has to be fairly ductile, and checking it with a file, it's definitely soft material. This has not been hardened, so I should be able to bend it. But the thing is, the bend has to be very localized to right here, because I want to keep this thing straight and I want to keep this part straight. So now with that weak spot right here, I should be able to bend it. So now I just need to be super careful not to overbend it. Oh, that might, uh-oh. Uh-oh, overbent it. But then I realized I could check if it was straight just by spinning it in the jaws of the vise itself. And that way I could just apply a little bit of force and check, and a little bit of force and check. And I got it fairly straight that way. So it's not perfect, but it's better than the old one, that's this one. And that was the better of the two. Ha! Close enough. So now I can finally put this thing together, but the way this thing is made is just incredibly rough. Like, look at the size of the clearance hole for that screw here, allowing for lots of tolerance in manufacturing, and none of the edges in this thing were deburred except for the very top. So I actually cut myself handling this thing, so I've been going over all the edges with a file and also smoothing some of the running surfaces because those ones were just machined. So I've been sanding them and filing a bit just to get rid of the high spots so everything glides a bit better. And there's a few voids in the casting here and here, but I have found that some of these machine surfaces, the file actually doesn't take very much off of these. So some of this actually has been case hardened, which is more than I can say for the Vevor lathe. Now I was just going to check the consistency of this screw with the scale on the crank and the dial indicator over here. So I'm just stopping on 1mm increments on the crank, and the dial indicator is 1mm per turn. And I did that for the entire 30mm range of my dial indicator. And for consistency, I also took a set of reading moving the table back to the left. So when I was cranking the table to the right, I had a variation of about 0.1mm, which is not too bad, and the periodicity is 4 samples. That crank is 4mm per turn, and I've been stopping it on the even millimeters, which is why I get that periodicity of 4. But when I cranked it back to the left, the variation I got was about 0.25mm, or about 10 thou. That's terrible. And if the surfaces for my thrust bearing are quite level, then I get that wobble. So imagine this is the thrust bearing, and this is the mount on the shaft. If it's pushing against a flat surface, it's not too bad. But if this surface is also crooked, then we get a wobble every turn like this. But why was it so much worse when I was cranking the table this way? But then I realized the way I've got this crank on there right now, this crank is actually pushing against this casting here, so that's effectively my thrust bearing this way, and that was making it much worse. So I just need to put a washer in there. And then checking the consistency moving left again. And plotting that again, my left movement is much more consistent than it used to be, but still less consistent than moving to the right was. So I've been starting to wonder if that bracket at the end of this table is accurate, so I took it off. So checking it over, the front and back surfaces for the thrust bearings are about 0.2mm or 1/8 thou out of square. But both the back and the front actually need to be parallel to this surface. So I made this block of wood, which is fairly parallel, put that in here, and I've been checking against this surface, which I've now sanded to be fairly true to the back surface. And referencing the back surface, checking this bearing surface, it's not actually that far out. So the culprit is this surface here. So I've been thinking about trying to chuck this up on the lathe somehow, but that would be difficult with the jaws, and this is not a reference surface. So I think I'll just sand this flat. So I mark where the high spots are, and I'll just try to sand it by hand. This took about 20 iterations, but I've got the variations now down to about 1/20 of a millimeter or about 1/1000 of an inch. I think this is as good as I'm going to get it. But the front bearing surface is still out of parallel with the back reference surface, and that's something I can't fix with sanding. Well, I have a nice machined surface in there now, but I can't say for sure that it's better than before. And now cranking it left, it's as consistent as I could hope for with this table. But cranking it to the right, I don't need to graph that to know that it's terrible. It seems like I just can't win with this table, and now I'm probing the other side of the thrust bearing down here with this dial indicator. So I'm seeing that jump around by about 1/8 thou or 0.2 millimeters. So now looking at how this thrust bearing is mounted, the shoulder that it pushes against here is just 0.4 millimeters wide, or about 16 thou, and this part of the thrust bearing has got a bevel on it, and that's considerably wider than this, which is to say this thrust bearing, especially having a little bit of leeway side to side, can kind of sit on here at an angle if it wants to. I just milled a larger hole with square edges in this washer, and that's a very snug fit on here. And looking again at how the lead screw goes through this nut, there really is quite a lot of play on here, so no matter what I do, I'm still going to have a little bit of backlash in here. And for the thrust bearing that goes in here, the other bearing surface is these two nuts jammed against each other. But I've learned that nuts like that jammed against each other can't be counted on to be perfectly perpendicular. But I don't know of anything I can do about that surface here. And this is a consistency I now have for left and right. Not as good as I'd like, but I'll just have to live with it. The front and back lead screw consistency is much better than that, and that's without me having to mess with it at all. I guess this milling table just wasn't meant to be as precise as I was trying to get it. And this is not sponsored in any way, but Vevor product support wasn't too bad. They even offered to refund me part of the purchase price after I pointed out that the replacement lead screw they sent me was bent and it was probably made that way. What I don't understand right now is, how did I ever get on without a metal lathe?